Okay.
You were saying I go to bed at 7:30.
Yeah, you bet that's 7.
Like bedtime isn't 7.
Yes, it is. What time
Yes.
is it? 8? Oh, you're not.
Yes, okay, 11. I did not understand 11.
Okay.
I wrote down the back of the book.
So some of you have asked about question number 3.
Yeah.
Excuse me, number 4. So here's kind of what I've got. I've got a
If he wants to talk
resistor
about
here.
it.
We'll put in a light bulb just for individual. Okay.
That's what the book said. I just kept reading the book.
I got more from this.
Okay. So what we're going to get into
The first
today
lesson,
is
right?
this
Like
concept
something.
of resistance.
For this, like,
So when you look at question number 4, because there's some important things that I'm going to segue into what we're going to talk about today.
I just basically wrote that.
So light bulb is connected,
Okay.
2 copper wires, equal lengths but different thicknesses. The thick wire connects to one side, positive terminal, and thin wire to the other. So what you'll see is that cross-sectional area does impact the resistance of the wire. Okay? So the bigger the wire is, the less resistance that there is, which is true. Okay? So imagine that you have, like, Chipotle has been delivered, let's say with Chipotle. So Chipotle has been delivered to the front office. Okay? That's your voltage. That's your willingness to move. Okay? And let's say that there's 2 ways you can get down to the office. One option is that we have a very narrow hallway that's only about this wide. Okay? You still have the same desire to get down to the office to get your Chipotle, but with a very narrow wire, it's going to be you're going to run into a lot of resistance because you're going to be running into a bunch of people, okay, because it's very narrow. The other option is you have this big, massive, wide highway to get down there. You have the same voltage, you have the same desire to move. But obviously with a much bigger cross-sectional area, there's less resistance. So with this program, I can't model a thicker and thinner wire, but what I can do is I can put a resistor on one side of the light bulb. So the thinner wire, remember this for today's lesson, the thinner wire is going to have much more resistance than a thicker wire does. So one of the things you need to focus on is what's staying the same and what's changing. So I've got this non-contact ammeter. I just moved over it, I get a reading. So I've got 0.45 amps on one side of the resistor. If I move it to the other side, I still have 0.45 amps. I move it down here to the bottom, it's still at 0.45 amps. Yes. Well, no, this isn't the desire. It's the same current flowing through per unit of time. Right? Now, in terms of voltage, so when you look at like voltage drop, so if I take this voltmeter and I measure the voltage across the battery, that's going to tell me what that desire is for the whole thing. So this is a 9-volt battery, okay? So that tells me this is basically how much energy you're getting when these electrons flow through the battery. It's giving them food, it's giving them energy. So you're going to lose that as it goes. So in this situation, because the light bulb and the resistor both have the same resistance, you have the same voltage drop across them. But the entire drop across the whole thing is 9 volts. So each one is 4.5, but the total drop across everything is 9. Now, don't sit down and go, oh, the voltage always gets decreased by a half. It only gets decreased by a half if the resistances are the same. So if I come in here with this, and I increase that resistance to say, I don't know, 34 ohms. So I still have a 9 voltage drop across the whole thing, but now if I measure the voltage drop just across that resistor, Notice that that's like 6.95 volts. Now, the total voltage drop is still going to be the same. But what that means is that if I put that big, massive resistor in there, that's going to lose a lot more of that energy because it has a lot more resistance than the light bulb is. But even within that, you'll notice that even though I put that bigger resistor in there, the overall current in everywhere in the system stays the same. There's less current because there's more total resistance in the system. Still the same voltage, but the current is staying the same throughout everything as long as it's a simple circuit where everything is in series. Shannon.
So the total drop, the total voltage drop is 9, but that
Yes.
resistor went up. So does that mean the light bulbs went down?
Yes. In terms of the voltage drop, yes.
Okay.
So now, if I measure the voltage drop across that light bulb, that's like 2.05.
Okay. And what do you mean voltage drop? What does that
Voltage drop is how much energy is lost from one side to the other. You can think of it as like the height of the dam. Okay? So the total height of the dam is 9 volts. So I'm losing 2.5 at the bulb. I'm losing the vast majority of it at the resistor. But if they're both the same resistance, they're both dropping half. Okay, does that make sense? Okay. So on question number 4, and again, it doesn't make any difference which direction that's flowing. So here's what I want you to remember going into today's lesson. If you want to have a resistor, there's 2 things that you can do. You can actually install a resistor, or the other thing that you could do is if you have like a big wire and then you connect it to a smaller wire and then go back to a bigger wire, a smaller wire will in effect act like a resistor. Okay? But the current through the whole thing is going to be the same. Big, small doesn't make any difference. The voltage drop would be much bigger over this gap than it would over the bigger wires. Okay? So small wires, okay, and think about this, you're going to Chipotle, you want to get down there to the office. And you've got this big, massive walkway. And then all of a sudden it narrows down to like very narrow. And then it widens back out again. So that narrow portion is what's going to restrict the flow because that's more restricted in that space.
Does the voltage pick back up after it gets bigger again?
No, so what would happen is just like this. So that voltage drop would be occurring over that.
Yeah.
So if you measured the voltage drop across the big wire, it's probably going to be very small because there isn't much resistance. But then if you measured the voltage drop just across that very, very small, thin wire, that's where you would have a big voltage drop because that would be like a light bulb in the system. Okay? All right. Now, let's talk about question number 5. Okay? Because this is one of the important things that you've got to get. And I'm going to build this. Okay? So give me 1 second. And
Wait, which one? Yeah, I asked someone about that one.
I took
Like
Chem
it's a
2
summary, is it just a summary?
Yeah, pretty much.
Me and Gavin took Chem 2 Irish. What do you know about rate reacting? Yeah. What is a rate law? Wait. I'm trying to figure it out. I need to look at the allocations. Hold on, I need to look at the ad of
Too many
of this paper to see how.
Huh?
Like this paper.
All we have to do is
Hey.
go to games and actually.
What is with you?
It's free games.
Why do you rate these?
I feel like I make things like they don't need to be as hard as I think they do. I feel like, I feel like I make things harder than I think
I'm
they
just
do.
playing.
Like they're not actually that hard, but I overthink.
I think I overthink this class way too much.
It's just easy to do, I think.
Yeah, this is supposed to be like really complicated.
Oh,
isn't it? It can't just be that simple.
Yeah.
Wii Sports rated R.
Actually, long ago.
Is Wii Sports rated R?
I've had them on in here for once I had carrots in my bag for so long they turned into one.
Ooh.
Like, I forgot about it.
Inside thought.
You gave one to Adam?
That's disgusting.
No, that's not one of those.
They would literally be liquid. It would be straight from scratch.
This is giving the same vibes as the.
Yeah, how long is this
Oh, today?
He just said
That was my lunch.
he said
Oh, no, those were.
Okay, so let's chit chat. Question number 5.
Question 5.
So you've got this diagram, and here's what's going to be important. All wires are made of the same material, have the same diameter, rank in order from largest to smallest occurrence 1 through 4. So you can again, so what's going to happen is that, and again, I'm starting to paint this picture. So what you have are these two wires that are in parallel. Okay, this is not a series. So it comes down, it splits, it goes like this, and then it rejoins. Okay. So if your mother cooks in parallel, okay, so what's going to happen is that she's got to feed both of you the same amount.
Yeah.
So this right here is the amount of food coming into the kitchen. And then it's going to get split between the two of you. Okay? So where are you going to have more food flowing? Into the kitchen or out to the table? Into the kitchen. That's where you're going to have the most amount of food. But if your mom cooks in parallel and she loves both of you the same, as all parents do, they love all children the same. That's any of them. And I'm not saying right or wrong. Hey, I was one of 5, okay? But I was the baby in the family, so everybody claims that they love me the most as well. They should have.
Okay,
It's
very
true. So I was the golden child. So
Okay.
you got this. What?
I don't believe it.
Oh, it was. Because there was actually a big age gap between, like, it goes, my 3 sisters, my brother, and my mom had some miscarriages, so it was like a 7-year gap between me. So I kind of grew up, and I watched what made mom and dad mad, and so I wouldn't do that.
Yeah.
Yeah,
Because-
so,
I
yeah.
did the same thing.
Like, oh, that, hey, mom and dad mad, I won't do that, you know?
You know that makes
You know what? Okay, I get that. I get
They were
that.
stupid, they didn't know that, I did.
Oh, so smart.
So,
Like,
yeah, your brother and, you know,
I'm the oldest. I was the touch dummy, man.
I was all right, so here's the point. So when you look at this diagram on question number 5, the top is the kitchen. That's the food flowing in. Then it's going to get split. But everything's the same. And then it's going to rejoin on the other side. So you can also think of it as like a river analogy. You have the water flowing in. It splits into 2 branches on the river, and everything is the same.
How do I know that's parallel
Hey,
versus series?
one more warning, otherwise I'm gonna separate you two.
Because if it's in series, it would all be one thing. So here's the other way that I know it's in parallel. Is that, notice that this current is flowing through this entire thing. This is how I know that it's in parallel. Because if I cut that,
Still goes.
the current still flows.
How do I know that on my assignment when we're gonna have diagrams?
Huh?
How do I know that on my assignment?
I can't.
You just have to think
Brother.
conceptually.
Well, no,
But
because
we're-
like, they're in parallel.
Wait, because they're parallel lines?
Yes.
Is that it?
Yes!
Well, no one told me this, Coach. He told me yesterday. No, you taught me about a kitchen.
yesterday.
All I learned yesterday, literally showed us with
All
the
I learned
thing.
yesterday was
I went to
I didn't know it was actual
I
parallel lines.
Okay,
Now
but
I
what
know.
if you just
Why
have
do
a
we call
box?
them parallel?
But what if you just have a
They
box
don't have to
and you have
technically be
2
parallel.
They don't have to.
Like, I can do this,
You just have to split it.
it's still in parallel.
Don't
Okay?
It's
still kind of parallel though. Kind of.
It is not parallel.
That bothers me.
Okay, parallel.
Where do you have a side by side between?
Anyway, back to our story. Notice that the top line is 0.13 amps because the whole thing is 0.26.
See,
So
the bottom one is going to be
also
.13.
0.13
Ooh.
because of the fact that it's being split.
Yes.
That's
So when you answer question 5, if I see 1 comma, I'm going to flip out. you either put greater than, less than, or equal to.
There are no commas in my answer.
There are no, should be no comments. What?
I thought since it was in parallel, the amps would be the same or the same.
No.
Bad boy,
So it
Gavin.
splits into two because
Because everything's the same, so it has to feed both sides. The same, everything's gonna get the same, but so, notice here, this 0.26. If I move this up here, it drops to 0.13. So I've got 0.26 coulombs per second going in. But that's gonna split and go 0.13 and 0.13.
And they come back together.
And then they come back together on the other side, and then you're back at 0.26.
Real quick, can you build a series so I can side by side visual? Just real quick.
So,
Is it literally just like one, like it's like a
hold on.
rectangle?
So the only difference,
Still the same current,
okay?
just less power.
Oh, but there's no splitting off. It's like,
Yeah, so
Oh.
that's,
Oh, and that's our house ain't that where if something goes off, it all goes off.
yeah, so if, let's say that here, let's put a light bulb in.
Pass me one behind
Yeah.
you.
So
In parallel.
Huh?
the current remains the same.
Thank you.
On both, if everything is the same.
Thank you, Shaq.
Then would-
Is it the same as like the wires are the same?
Don't deal with voltage later. Don't confuse this right now.
Don't disrespect.
don't disrespect.
Don't disrespect me.
Not like.
Wait.
Okay.
Both of
Why is the light bulb like that?
So let's say this is your house. You have one light bulb and then you have a
Why
resistor
is it
known
not
as a
even
toaster.
like?
Okay, a
right
toaster
angles?
is just a really big
Oh, no.
resistor.
Okay, just one.
It is, that's all it is.
It is.
Because it gets hot,
No, I
because
was-
you're forcing the electricity through it, and it doesn't like it, so it gets mad, the chihuahuas get upset, and the chihuahuas give off heat, and you make toast.
Would it hurt?
Oh.
Okay?
I was shaking my head at the light bulb.
What about it?
Why is it like that?
So you and
Why is it
Randy
like
do that.
90
Would it-
degrees?
would it-
No. Rotate it up.
It's,
Have you ever got
I don't think you can control it.
What?
Exactly.
Yes, he can.
Oh, you can.
Have you ever got the
Why is it
there,
tilted?
better?
No.
Meh.
What?
Okay. So, here's the story. If your house was wired in series, you have a toaster and you have a light
It
bulb.
won't hurt.
If the light bulb goes out, okay, everything stops.
That's bad.
Not good.
So like you literally could not shut off a light bulb. It could not go out. If it did, the whole house would go dark.
That's bad, Barry.
No
I'm
way.
just saying. I'm not saying it's good or bad. I'm just saying. What?
So if mom could like for one, right? There's one wire. Then there's 26 amps that go through that. There's 26 amps that go through the one wire. But if
Okay.
you split into two, the dinner would get split, I thought. Or like
You
said
would,
get
but
the same
everybody
dinner.
would still. Okay. So, stay with me here, Gavin.
Okay.
Stay. Oh, hear me.
So this is you being an only child,
Me too.
and your mom is cooking at 0.2 amps per second.
Okay.
Okay. You're the only child.
Right.
Now, if I introduce a parallel circuit, okay, so now I'm going to cut this, all right?
Okay.
Guess who chicken?
I think we're spending more time
Chicken
putting together these wires.
This is not a 90 degree, you already get the idea.
This looks
Ugh.
Actually, you know
Ugh.
What is that?
So, I didn't say this was pretty, but here you go.
That's
Better?
not pretty.
Yeah.
That's better.
That's still
Okay.
ugly.
So now, this is 0.2.
See.
Yeah.
So that's like, because they're technically not the same length and everything, so it's a little bit of difference.
Okay.
So this is 0.2, that's 0.13, and I should be able to show, no resistance. This has a little bit of resistance built into the wires. But here's the point. So what's happening is that I've increased the current by putting two things in parallel. So mom has to buy more food. So when your sibling comes home, your mom has to buy more food to feed both of you at the same amount. So the battery's going to run down faster if you have things in parallel. Because you have to feed the two things the same.
But wouldn't it be 0.2 and 0.2 if they were the same?
No, it's getting split between the two of them. Okay? It would be 0.1 and 0.1 if everything was the same. So, look at this being 0.2. Okay? This is 0.2. I'm going to cut this wire, and then I'm going to reconnect that. So, which is a poor example because these wires don't have any resistance. Let me put another light bulb in here.
Goes that other wire.
Hold on, I got too many wires.
It is. Where you gotta connect it to the ball.
Why is it negative?
Like whatever you say, something you have to say.
Yeah, I don't know. That's what the book
He's
said.
like,
Both are like,
just
because
The negative doesn't make any
I'm not
sense.
mad at you. I'm
Oh,
just-
that's the one you said.
Yeah, that's what I said, don't.
You don't have to cool one.
It's the odd two. What did they just say right now, bro?
What are you saying?
Okay, yeah. So, I'm gonna cut this, okay? Notice the current is 0.2.
Oh!
This is your home alone. If I connect this, and now I'm feeding 2 light bulbs, notice that the current went up.
You need more current.
Because now you're feeding 2 light bulbs instead of just 1.
Okay.
But it's still getting split between the 2.
Yeah. But say we're feeding 50,000 mallets, we need a bigger battery.
Bro, just stop
Can
talking.
we get off these analogies?
Alright, just so
What if we had a
million
billion people, bro?
Anyway,
Okay, I got it.
with all that said, your answer to problem 2 should start with a 3.
I got that.
Oh,
What if this was
Like a decent one.
0.00?
kind of.
All right.
Your answer to number 6 should
probably
start with
fine,
a 1.
Yeah.
Hey.
Which one?
Your answer to number 10 should start with a 3. Yay! On number 12, make sure that you have 2 answers, one for B and one for C.
Hold on. For 12, when you want direction, you mean like left, right? Or what do you want, like direction?
Just put right.
Where's it's right here.
Direction and
Your
magnitude.
answer to number 14.
Oh yeah.
Your answer to number 14, when it asks for EMF, that's the electromotive force, which is just the same thing as voltage. Your answer to number 14 should be around 14.
Okay.
It's just 12.
Yeah.
Right?
I wasn't sure what that was.
What, Shannon?
Micro?
What it was asking for.
Sign of the dark matter.
It's also in the
On which one?
Ah.
I remember.
No, they're all of these answers are
Because it starts
possible.
with, so for B, it starts with 5,
Mhm.
and it loses 3, because 3 goes this way.
Okay.
And then, so
Anything
1 has
else?
to go
Once
this way,
my
right?
soul.
No, not sold.
Yeah.
What?
Oh wait, I get it. So this is 2 at C. And then, so 2 has to go this
It's
way.
literally make them add
But then it
up.
loses 1, because 1 goes this way.
Make
So
them
1.
add up to the total.
So, okay, and the question, IB,
Okay.
Like how much is there?
Okay.
Which is 1.
So I see.
And the width.
where's current, wait, so current IB and IC, so is it just in segments B and C, so IB is in segment B?
Yeah.
Okay. Oh, I was sitting on my hand. So IB is 1. And then
One of these days you're not
that was really simple. I didn't understand it.
It's just like weirdly worded too.
Yeah.
So bad.
I had
What's the unit? Yeah.
46.
Dennis trying to be different.